Okay, I think we can wait for join. Okay, I think we can start. Uh, uh, Firstly, I want to talk about what we learned in the previous lessons. We learned the basic idea of engines, where they are used, and the main parts of an engine, including both moving and fixed components. We also saw that an engine is not a single part, not a only part, but a complete system where many components work together in a very precise order. Now, in this lesson, we are going to focus on how the engine actually produces motion step by step. This means we will go inside the working process of the engine and understand what happens during the operation. To make this easier, we will study one of the most important engine systems, which is the four-stroke internal combustion engines. You can see in here, this is four-stroke internal combustion engine. This is the most common type of engine used in cars and many other vehicles. So understanding it is very important. The four-stroke engine works in a repeating cycle. This cycle is made up of four main stages, and each stage has a different role in producing power. These states are called intake, compression, power, and exhaust. I will talk about deeply. Uh, Actually, in this lesson, we will not only name these states, but also understand what actually happens inside the engine during each step. We will see how the piston moves, how the valves open, and how can I say, and close, and how fuel is used to create energy and motion. At the end of the lesson, you will clearly understand how an engine produces continuous movement using a repeating cycle. This will also help you connect all the previous topics like engine parts and energy conversion into one complete working system. So now I think we can talk about four-stroke engine. A four-stroke engine works by repeating a continuous cycle. This cycle is the process that allows the engine to produce motion and power. The reason it is called a four-stroke engine is because the full working cycle is made up of four main states. You can see in here. By the way, we have two-stroke engines, but I will talk about four-stroke engine. But in the next lessons, we will talk about two-stroke engines too. These states are called strokes, and each stroke represents one movement of the piston inside the cylinder. So in simple terms, a stroke is the movement of the piston up or down. In a four-stroke engine, the piston completes four movements to finish one full cycle. Now let's name these four strokes. The first stroke is the intake stroke. What's happening? The second stroke is the compression stroke. The third stroke is the power stroke. and the fourth stroke is the exhaust stroke. Each of these strokes has a different function, and all of them are necessary for the engine to work properly. Now let's understand the general idea of the cycle. Uh, During the intake stroke, uh, the engine takes in a mixture of air and fuel into the cylinder. During the compression stroke, this mixture is compressed to make it more powerful for combustion. And during the power stroke, the mixture is, how can I say, ignited, and this creates an explosion that pushes the piston down and produces motion. And finally, during the exhaust stroke, the burned gas uh, removed from the cylinder so that the process can start again. This cycle repeats continuously while the engine is running. So we can say that the engine doesn't produce power only once. Instead, it produces power again and again in a repeating pattern. You can think like cycle. This repetition is what creates continuous movement in vehicles like cars. Another important idea is that timing is very important in this cycle. Each stroke must happen in the correct order and at the correct time. If the timing is wrong, the engine will not work efficiently or may stop working completely. That is why engine components like valves, pistons, and camshaft must work together in perfect synchronization. Now let's connect this idea with what we already know. The piston is responsible for moving up and down during each stroke. The valves control of the flow of air, fuel, and exhaust gases. The spark plug you can see in here. Ignites the fuel during the power stroke, and the crankshaft converts the piston's movement into rotation. Uh, all of these parts work together to complete the four-stroke cycle. So the four-stroke engine is not just a simple process, it's a carefully designed system where every part plays a role in each stage of the cycle. Okay, I think that's all for this part. Now I will make summarize what we learned. A four-stroke engine works in a repeating cycle with four states: intake, compression, power, and exhaust. Each stage has a specific function, and all states work together to produce continuous motion. In the next part of the lesson, we will look at each stroke in detail and understand exactly what happens inside the engine step by step. Okay, now I will talk about deeply for stroke cycle. Okay, this is the most important part of understanding how an engine actually works, because these four states are what create continuous motion. The four strokes are intake, compression, power, and exhaust, like I said. Each stroke has a specific job, and all of them must happen in the correct order for the engine to function properly. Okay, now uh, we can continue step by step. Firstly, intake stroke. Uh, you can say emme zamanı in Turkish. The first stage is called the intake stroke. During this stage, the piston moves downward inside the cylinder. At the same time, the intake valve opens and the exhaust valve stays closed. As the piston moves down, it creates a low pressure area inside the cylinder. This low pressure causes air and fuel mixture to be pulled into the cylinder. So the engine is basically, we can say, breathing in during this stage. The cylinder fills with a mixture of air and fuel, which is necessary for combustion. Without this mixture, the engine wouldn't have anything to burn, so power couldn't be produced because we need something to burn. We can say that the intake stroke prepares the engine by bringing in energy in the form of fuel and air. Now, compression stroke, we can say sıkıştırma zamanı in Turkish. After the intake stroke, the compression stroke begins. During this stage, the piston moves upward inside the cylinder. Both the intake and exhaust valves are closed tightly. This traps the air-fuel mixture inside the cylinder. As the piston moves up, it compresses this mixture into a much smaller space. This compression increases both pressure and temperature inside the cylinder. Now I will talk about why is this important. Because a compressed mixture burns much more powerfully than a loose mixture. So compression makes this combustion process stronger and more efficient. We can say that this stage prepares the mixture for explosion. At the end of this stroke, the mixture is highly compressed and ready for fire. Now the power stroke. This is the most important stroke, I think. We can say iş or yanma zamanı in Turkish. Now we come. This is called the power stroke. At the end of the compression stroke, the piston is at the top of the cylinder. The air-fuel mixture is highly compressed. At this exact moment, the spark plug produces a spark bougie. This spark burn the mixture, ignites the mixture. When the fuel burns, it creates a very fast and powerful expansion of gas. This expansion creates high pressure inside the cylinder. This pressure pushes the piston downward with strong force. This downward movement is what produces usable power. This is the only stroke where the engine actually produces energy that can be used for movement. So we can say that the power stroke converts chemical energy into mechanical motion for engine. This is the heart of the engine cycle. Without this stroke, there would be no movement at all because we can't burn the air-fuel mixture. Now and finally we have exhaust stroke, exhaust zamanı. After the power stroke, the exhaust stroke begins. During this stage, the piston moves upward again. The exhaust valve opens, you can see it here, while the intake valve stays closed. As the piston moves up, it pushes the burnt gases out of the cylinder. These gases are the result of the combustion and no longer contain useful energy, so they must be removed to make space for a new cycle. This process is called exhaust. Okay, in conclusion, we can say that this stage cleans the cylinder and prepares it for the next intake stroke. Without this step, waste gas would remain inside the engine and reduce efficiency. Because of that, we can't do a cycle. Okay, now I want to talk about how the cycle works together, how these all stroke works together. The engine doesn't perform these steps only once, like I said before. Instead, it repeats them continuously while running. The correct order is intake, compression, power, and exhaust. After exhaust, the cycle starts again from intake. Dissipation happens very fast, many times per second. Like I said before, we saying devir in Turkish. Each cycle produces a small amount of motion, but together they create continuous rotation in the crankshaft. That is how a car or motorcycle keeps moving smoothly. Now, I want to talk about a very important point is timing and coordination. All four strokes must happen at the correct time. The valves must open and close exactly when needed. The spark plug must burn at the perfect moment, must ignite at the perfect moment. If timing is incorrect, the engine will not run properly. This coordination is controlled by engine components like the camshaft and crankshaft working together. We have talked about crankshaft, camshaft at our second lesson. Now let's connect this with engine parts. The piston moves up and down during all strokes. The connection rod transfers motion to the crankshaft. The crankshaft converts motion into rotation. The valves control air and exhaust flow. The spark plug ignites the mixture. All these parts work together in perfect synchronization. And I want to summarize everything. A four-stroke engine works in a repeating cycle. The four strokes are intake, compression, power, and exhaust. Each stroke has a specific function. Together they convert fuel energy into continuous motion. This cycle repeats continuously while the engine runs. That is how engines produce the power needed for vehicles or machines or something. Now I talked about all of things. I think that's all for today. We studied the four strokes of four-stroke internal combustion engine in detail. We learned that the engine works in a repeating cycle made up of four main states: intake, compression, power, and exhaust. Each of these states has a specific function. During the intake stroke, the engine takes in the air-fuel mixture. During the compression stroke, this mixture is compressed to increase its pressure and efficiency. During the power stroke, the spark plug ignites the mixture, creating an explosion that pushes the piston down and produces motion. And during the exhaust stroke, the burnt gas are removed from cylinder. We also saw that this cycle doesn't happen just once. It repeats continuously while the engine is running, many times per second. This repetition is what creates continuous movement in vehicles like cars and motorcycles. Another important idea is that all engine parts must work together in perfect timing. The piston, valves, spark plugs, and crankshaft, all of these play different roles, but they must be synchronized for the engine to work properly. So the engine is not just a collection of parts, but a complete system where everything is connected. Okay, understanding this cycle, we now have a clear idea of how engines convert fuel energy into motion. This is the basic principle behind almost all internal combustion engines. Okay, I think it's enough. In the next lesson, we can explore different engine types or compare systems like two-stroke and four-stroke engines in more detail. Okay, thank you for listening. Goodbye.